Alright, let's see here if I can get the stream up and running. Perfect. My voice is a little bit raspy today. It's been a hectic couple of days, but we're going back here, putting in 1 or 2 hours to add some to add for loops. So I'm gonna find a good playlist here. I think this one's good. There we go. And we'll get going. So let's see, that's working fine. Let's pull up the pop-out chat. There we go. Alright, so we ended off yesterday with a little update. So currently if we just run hello world, it seems like I messed something up, which is a great start because it just worked. Oh. Looks like I have... Yep. There we go. There we go. We had our hello world, and this is how the... this is what the assembly looks like. So I'll definitely want to change the randomly generated strings at some point, but I'm thinking of maybe changing it to something more representative of the token it originates from. But currently I don't really care. So we're keeping it this way for now. Like here, this is oh wait, no, this is hello world, so this is actually accurate. But if we compile the function, there we go. Here you can see that the functions still have their label, so main is here and we have print me. A change we made yesterday was to split out the subsequent code blocks into their own labels, and of course if you have a function that will always have a code block, so I want to make these two be the same code block, which they aren't at the moment, but that it all comes with time. But this is all in a way to make it easier for me to implement for loops. So we can see here that it runs print me, it finds this label and goes here, and then it runs puts with this this whole line here. And if we open the file here, we open func, and then we run we run the assembly here, we can see that it runs print me and print me runs puts, and we can see that that's the case. So this is main runs print me, and then print me, which is this one, runs puts. So that all works fine. But now if we compile for we're gonna not get anything, because that looks this no, that's let's see here. This is how for loop. Okay, so it still has a print me. So we can see here how in the puts code block we have nothing, because there's no code generation currently for the for loop. But that's what we're gonna fix today. So we're gonna make the it resemble something like this. Now this is the idealized self-written assembly. But basically what this does is when we reach a for loop, we call the new code block. So for like example, loop ABC, and then we get into we get the puts call here. I don't know why I run racks here. There's probably a left. I don't. If I do this and just ask them, yeah, exactly. So this all works, and then here we decrement the RBP. So this should actually be in print me. Cleaning up my bad assembly here. There we go. So basically what this does is it runs, it adds 10 to the RBP register, which is, I think that's a saving register. Give me 1 second. KTH. This is the ref cheat I've been using. So there was one thing. Call these saved registers. Yeah, exactly. So RBP, RBX, and these are not going to be written over if you run another register. So for example, if I write 10 to the racks register here, then if I, for example, run printf after, which is a libc function, you've probably seen if you've done a hello world in C, then libc can write over that and add garbage data basically for us to racks. But that is not the case if we run RBP. So we want to run that. Otherwise, you can use push and pop. So I could run racks here, or actually I use racks down here. But if we say that I use RBX, then I can run. You want to do push RBX, and then you do pop RBX. I don't know exactly how this works at the moment. I'm a little bit unclear on that, but basically this is how, in my limited understanding of assembly, it would work. But currently, we're doing it simple. We have no variables at the moment, so we'll keep it to RBP. So basically, what we want to do is this will be our for loop. How do you do comments in assembly actually? Yeah, okay. So this will be equivalent to our for loop, and this is end for. So basically, this is when we create our. This is basically the index, and this is our code block. And then in here, this is the I minus minus that we're doing. Because we're doing if it's equals to 0. Because we start, I don't actually know. I'm not really, I don't really have an understanding about how the conditionals work yet. So you have a jump, not 0. So if the conditional, basically, if I is greater, this is if I is equal to 0. Or this is actually continue if I isn't equal to 0, or I is greater than 0 in this case. And if that conditional fails, then we return back to the print me function, which is basically we end the for loop. So this is what we want to implement today. It shouldn't be that difficult. Of course, implementing, if we look at the code here, we have no index. Like, we have no... I guess I could do 10 here. That would add a simple way for us to actually have have this kind of push the value. But I do want to add something like ranges to my language, so you can do 2 to 10. I don't really know how to do that with this jump not 0, so for the start, I'm just doing 4, and then we can figure it out later. So let's open up the backend. The parser we already did yesterday, so that's all fine and dandy. So I think where we want to go is down here. Really. So when we use an AST4, let's look at the assembly. Let's split this horizontally and open the program assembly for that. So when we want to first move 10 into the RBP register. So let's handle that. Builder and then mov RBP 10. And this should be that. And now we want to generate the code block. So here in my backend here, in my x86 backend, we want to do a x86 do code block backend, and then we send in the nodes, which would be the n.codeblock.nodes. And here we have the label. And when we have the label, then we just run string star write string builder call string star write string builder and or label. That should be it for that. Now there are some interesting things here, because the code blocks here, they only include this, which is like the code generation part, like the code block generation currently only includes puts, not the actual interesting part, which is the returning in the for loop. It only includes this. So the question is, in my code, how would I add more strings on top of the old one? And that's actually, I don't think it's crazy to add a supply for your own builder here. So let's say builder. Let's say what do we call this? Child builder. Let's just call it vendored builder. It takes in a string stop builder. And this is actually, I think we have, yeah, okay. So, sorry, I'm getting messages. So here we want to go and actually, if vendored builder equals nil, then we run this. Then we have an actual builder. And we set that to a pointer to string stop builder, which we default to nil. Actual, we set this to vendored builder. And then we do, if actual builder is nil, then we create a new one and we set the actual builder to a reference for builder. Down here, all of this is actually the same, so this should be in here. Well, this needs to be, of course, here, and this uses actual builder. I really could just run this. No, I'm gonna do this instead. This should actually be its own function. Do code block vendored. Because they're so different, and this one shouldn't even return a label. Wait. Because the loop needs a label, which this one provides. Ooh, this is a little bit different. No, wait. So I fumbled, or I mixed up two different problems here, which isn't great. So, so, what do I do? Because basically, I need to return the builder as well with the do code block, but I do need a label for it. So basically, this is all the same. This is all what should be there. But this specifically, ooh, well, it should be two different then. Do code block, x86 code do code block unmanaged. So this node, and this returns a label string and the oh, but this creates the builder. So we take in a builder here as well, I think. Just don't get in. Just do not get into any funky business. Like this. This is still needed. And this runs. This runs all of this code. And of course, this is no longer needed. And then this instead runs x86 do code block unmanaged with a backend nodes and the builder. And then we want to take this code for the for loop down here. Yeah, exactly. So when we actually generate the for loop, Now this should all probably be... I don't have a label here. It's gonna crash out. Because this requires... This doesn't return a label. Oh. Well, that's not needed. For builder. For builder. For builder. Writes it for builder. Call label. Only difference is that after this we actually want to add some stuff. So we do string star write string for builder. We add deck RBP job if not 0 for label, right? String star write string for builder label. For builder we do mavrax 0 and then we just rat like this. Run was terminated on line 3 by signal 11. That sounds dangerous. Signal 11 Odin. Oh, it's another name for seg fault. Oh yeah, shall return. There we go. So let's figure out why. Illegal hardware instruction. On line 17. Let's alright, let's build this. And then we do L, what's it called? LL DB for Marigold. Exit Marigold for Marigold. Run. Address not mapped to an object. So is this a null dereference that I'm stumbling upon? Yeah, well, that's right. What could this be? Well, it definitely has something to do with this part. Let's see what happens if I for the Marigold. Well, that's better. So now it's just the assembly crashing, but there's something here that it doesn't like. Run that. We create out, and then we assign to the backend. This should all be fine and dandy. Is something I did wrong with the unmanaged? Well, so... Oh. Well, that'd probably do it. Alright, same. Huh. Let's not... Since I don't really know what this... Where defer does it, so let's run it here. Oh, well, that didn't do anything. Builder init. Then we add the for builder. Let's remove code until it fixes itself. See this? Still segs faulting. I'm guessing it's here. Alright, let's... Alright, there we go. So it's definitely in the unmanaged. But why are you complaining? Oh. Am I never leaving the for loop? This runs with the new nodes. Let's see here. Fmt dot println code block, and let's print the node 0. See what's popping. Code block AC4. Code block AC4. Code block AC4. Why doesn't it pop the... What? This is so strange. This also needs... And then it reaches this because it does print the unmanaged after the for. And well, this, the unmanaged code block, this definitely runs without a nil, so that's not a problem at all. And this runs code block, not do code block, as it should, as it should. But why? So it runs this, and then runs this. But it doesn't seem like it consumes the node. Am I crazy? Yeah, AST4. What? Oh, wait. Oh, that was stupid. Oh, why doesn't it... What? Okay. Oh, why is it recursive? Because I made it recursive, dumbass. Alright, so after the MOV 10, we don't have a new line. ML combinations of opcode and operands. Alright. So, main, it runs print me, it doesn't have a label. So if we go back to the back end, and when we do the... So this label doesn't exist. Got label. Label. No, it definitely gets a label. Oh, not in the for loop, no. No, that's right. Let's just see if I'm... So I'm not completely losing my mind. No, I'm completely wrong. Which would explain why... So... It's the for loop generation that fucks up. The call to the for loop. Which would be not this. Call print me, runs print me, and then the first thing in print me does a call and it doesn't work. So that would be this generation. So it goes through here and it runs an AST4. And that should be the call to the for loop, but that isn't the case. So that's this one. Oh. Oh, no, it's that one that breaks. No, wait. It's the call... Oh, the call in the main functions have broken. So the function declaration. Do code block doesn't work anymore. There we go. We have a for loop, and if I'm not... Let's actually make it generate a... Or actually, fuck it. Let's do this instead. For dump mg. If I'm not completely, this should print 100. No. Oh, because I don't do the ooh. Interesting. Ooh, because that resets the RBP. Do I dare attempt? So that runs indefinitely because, I guess, what's happening is if I go into the assembly, what that does, yeah, it resets the RBP for both, which is wrong. What it should do, I actually have to, 1 second. All right.